Hello class and welcome to chapter 2, section 6, and this is part 2 of this section. So we're continuing on to talk about ratios and proportions, but we're going to do it with some more complicated problems. So yesterday we worked on just understanding what is a ratio, what is a proportion. Today we're going to work on solving for more variables and then applying those with real world context. So we'll work with the same vocabulary as yesterday and we'll apply those things with some problems. So we left off with 3a last time, so here is 3b. We need to solve this proportion. So the name of the game here with these equations is to cross multiply, find the cross products, and simplify. So all we have to do is multiply across and then simplify. So what we should get here is 4 times x plus 4. So 4 times the quantity, x plus 4, is equal to the other cross product, 12 times 3. I know that's 36. So this is the expression we get when we cross multiply. From here, all we would have to do is simplify. So we distribute that 4 to both terms. So we should get 4x plus 4 times 4 is 16. And again, that's equal to 36. And notice what we have here. Now we have a two-step equation, which we've already talked about in this chapter. So if we could subtract 16 from both sides, 4x would equal 20. Let's subtract 16 and minus 16. 16 minus 16 is 0, so that goes away. 36 minus 16 is 20. So what we should see is 4 times some number will equal 20. So 4 times what gives me 20? If you're not sure, you can divide both sides by 4. And x, that goes away. X will equal 20 over 4, which we know is 5. So x has to be 5. And we can plug that in and think about it here. 5 plus 4 is 9. And 9 over 12 is equal to 3 over 4. 9 over 12 is equal to 3 over 4. And you can tell that because 9 divided by 3 is 3. 12 divided by 3 is 4. These are the same fractions. You could check that in a calculator. 9 over 12 is 0.75, and 3 over 4 is also 3.75. So with these steps, we can solve this proportion, cross multiply, and simplify. So there you had your original. Go across, find the cross products, simplify, subtract, and divide. That's how you find that x equals 5. So there we have it for that example. Always with these proportions, multiply across and simplify. So we can do that. Not too bad. So 3c. Here we're asked to solve this proportion. So we'll do the same process as the last one. The first thing we need to do, multiply across. So r times 10 is just 10r. Equals 9 times 7, which we know is 63. Now to solve for r, let's notice the variable r is what we want to get by itself. But there's this 10 attached to it, and it's attached by multiplication. So to get r alone, we have to get rid of the 10. We get rid of it by doing the opposite of multiplication, so we divide by 10. And if we do that on the left, we have to also do it on the right. So r, that cancels out. We should have r equals 6.3 divided by 10. We can move the decimal just one to the left. So r has to be 6.3. So of these answer choices, we should see letter choice C. With just a couple steps, we can solve this proportion, get that number, and get the right answer. All we have to do, cross multiply, and divide to simplify. So the first thing you always do here, one is cross multiply, The second thing you need to do is divide, and that will solve for your variable. So the first thing, cross multiply and then divide. So we did that, and then we divided by 10. That's how we get this answer. These two steps will get you where you need to be on all these proportion problems. So for 3C, there we have it, 6.3. So here's one more that we can think about just with a couple steps. So we just said first step, cross multiply. This one's interesting because we have some distribution to do. So 8 times the quantity x plus 6. We have to think about this as all one thing in parentheses. So 8 is times x and the minus 6. So 8 times the quantity x minus 6 is equal to 16 times 5, which we can check that really quick. So 16 times 5, 6 times 5 is 30. 5 times 1 is 5, plus 3 is 8. So 16 times 5 is 80. So here we have this now after we found our cross products. Now we need to simplify and then get our variable by itself. So 8 times the quantity x plus 6. Well, I know that I can divide this 80 by 8 and get a whole number. And we have a multiplying by 8 over here. So that's something we can easily divide away to make this whole thing simpler. We could distribute the 8, but that's making it more complicated. We know we don't need this here anyway, so we can divide it away. So if we divide both sides by 8, these 8's over here cancel out. So we just get x minus 6. And on the right, we know 80 over 8 is just 10. So x minus 6, some number minus 6 is 10. What's that some number got to be? Well, if we're not sure, we can, I'll switch colors here. We can add 6 to both sides. So, with one final step, our 6's go away. They cancel each other out. We get just x. And that's equal to 10 plus 6, which we all can agree is 16. So x has to be 16 for this to be true. And we could double check that if we wanted to. So 16 minus 6 is 10 over 16. Is that equal to 5 over 8? And this is just 10 over 16 is 2 times 5 and 2 times 8. So we just doubled 5 and got 10, doubled 8 and got 16. These two as decimals are the same, so as fractions they're also the same. So this is a proportion, and we know it's true. So that checks out. So D16 is correct. We solve for our proportion by cross multiplying and simplifying. So we have that. So here's our first real world example. Let's try to get down as much as possible, and if we need to pause so you can write down, we'll do that as well. So we'll circle and talk about what's important. So the ratio of a gear on a bicycle is 8 to 5. So this is going to be important. This means that for every 8 turns of the pedals, the wheel turns 5 times. Okay, so we're talking about the pedals turning and the wheels turning and how they happen together. So suppose the bicycle wheel turns about 2,435 times during a trip. So that's the wheel. How many times would you have to crank the pedals during the trip? Okay, so this whole thing is just a proportion. And there's one thing missing. So in a proportion, we have 4 numbers, right? It's a fraction with 4 blanks. You've got 4 numbers there, and they're equal. And here they give us 3 numbers. So there's only one of these 4 blanks is missing. That's the variable that we need to find. So all we have to do is set it up in a way that makes sense and then solve for what's missing. So 8 over 5. The best thing to do on these type of problems is to label the units. So the 8 is for pedal turn, and the 5 is for wheel turns. We've got wheel turns and pedal turns, And the difference between those is very important. So the 8 is pedal turns. So for every 8 pedals, we get 5 wheel turns. I'll just put 5 wheel. 8 pedals, we get 5 wheels. Okay, so this is the ratio that these go in. Every 8 pedals is 5 wheels. So if I pedaled 16 times, when I double it, I should get 5 times 2, 10 wheels, 10 wheel turns. So now they give us this huge number. Suppose the bicycle wheel turns 2,435 times. So we're talking about wheels. So we'll put that number in our denominator. 2,435 of these wheels. And how many pedals? X pedals. So how many pedals are there in this case? Well, what we're going to have to do is multiply across and across here. So 8 times this 2,435 will equal 5 times x. So we multiply just like we've been doing. Multiply across, and then simplify and solve for our variable. So this is the same proportion that we just wrote. Notice the pedal turns and the wheel turns are on opposite sides. Pedals are on top, wheel turns are on the bottom. Your units should be organized together like that. The same thing on top and the same thing on top with both fractions. So now you solve for what's missing by multiplying across, just like we said. So you start there, multiply across, find the cross products. So this is going to be a big number here. It's going to be equal to 5 times your variable. And then with one more step, all we need to do here, 5 and p are tied here by multiplication. So to get rid of the 5, if they're multiplied, we need to do the opposite. So we divide both sides by 5. And so p equals 3,896. So in other words, that's how many times you have to pedal, given 2,435 of the wheel turns. So this many wheel turns has to be 3,896 pedals, based on that ratio of 8 to 5. So that's our solution there. We just need a couple steps to get there. And again, that's cranking the pedal. So always, always, always label your units on these word problems so you know which number goes where. The units do matter. That's how you know how to set up your fractions. So here's 4b. We have some more real world context. So they say Trent goes on a 30-mile bike ride every Saturday. He rides the distance in 4 hours. At this rate, how far can he ride in 6 hours? So this rate, 4 hours and 30 miles, if that's the rate that's always going to stay constant, we can use that fraction and compare it to how far should he go in 6 hours at that rate. So all that is a proportion. So let's label and do our miles as our numerator. So miles, hours, more hours. We have 3 things to fill in, 1 thing missing. So we've got fraction, going to equal another fraction, and one of these things is missing here. So 30 miles. I'll put miles on top. Miles will be on top. I'll use M. Our hours will be on the bottom. H. So 30 miles. And in 30 miles, they rode 4 hours. So this ratio is going to be equal to what we get over here. So how far can he ride in 6 hours? So if this rate is still true, and he rode for 6 hours, how many miles is that? Well, this one we don't know. That's what we need to find. So this looks like something that we've already practiced. How do we solve this? We cross multiply. So 30 times 6 will give me a number. And I'll also do 4 times x. So 4 times x is 4x. And that's equal to 30 times 6, which is, let's check it over here for us. 6 times 0 is 0. 6 times 3 is 18. So 30 times 6 is 180. Now 4 times some number equals 180. This is multiplication. We need x alone. So to get that alone, we need to divide both sides by 4. The 4's go away, and we get x equals 180 divided by 4, which is 45. And the units for this is miles. M is miles. So to answer the question, how far did he ride in 6 hours? It's got to be D, 45 miles, based on what we've seen here. So there we go. Easy enough. With a couple steps, we write that proportion, cross multiply, and solve. So C, another short problem with a little bit of context that we can understand. So in a road atlas, the scale for the map, Connecticut, so we're talking about a little map that you look at, and they give you a scale so that you know how far apart the things actually are based on how zoomed in the map is. So the map says for every 5 inches, that's 41 miles. So what's the distance in miles represented by 2.5 inches in real space as you're looking at the map? Based off this rule. And this is a real thing. Every map has that ratio written in there. So 5 inches, 41 miles, and 2.5 inches. So again, we're given 3 of the 4 blanks we need to write our ratios. One thing is missing. So say we put inches in the numerator and miles in the denominator. We'll get 5 inches, and in 5 inches, that's 41 miles. So in 2.5 inches, or I'll use 2.5, in 2.5 inches, how many miles is that going to represent? This is an x, this is what we don't know. So we have 3 of the 4. We write this ratio, and from here we'll do what we now know is good and true. We will multiply across. So 41 times 2.5 will be equal to 5x. So like we see here, 5 times your variable equals 41 times 2.5. From there, you'll be able to solve for your variable just by multiplying and then dividing across as the last step. So here, if I bring my pen back, 41 times 2.5. 5 times 1 is 5. 5 times 4 is 20. Bring down to 0. 2 times 1 is 2, and 2 times 4 is 8. So 2.5 times 41 is 1025 with 1 decimal place. 102.5. So 102.5. 102.5 is equal to 5x. Next, to get x alone, we have to divide both sides by 5. And x will equal 102 divided by 5, which should be 20.5. So let's double check that. That looks good to me, but let's double check to make sure. So there's our original. We multiply across. We get the cross products like we said. We simplify. Notice the fraction. And then we divide because we have to get rid of this 5. We need d by itself. So d equals, there we see it, 205 over 10, or 20.5, which is also 20.5 as a decimal. So 20.5 is our solution. So then in real distance, based on the problem, it's 20.5 miles with our units. Okay, so one more problem with a little bit of context to talk about. We need to circle what's important. We'll be given 3 of the 4 things we need. and the fourth one we'll have to find. So looking at another map, same problem, we're looking at a scale. So 1 3/8 inches is equal to 750 miles. They tell us the distance on the map between LA and DC is 3 7/8 inches. What's the distance in miles between the two locations? So 1 3/8 over 750 miles is equal to 3 7/8 and that's this as a decimal over, we don't know how many miles that is. So this is the miles that we need to find, and this is our proportion. So we'll get 1.375x when we multiply across, and that's equal to 750 times 3.875, so a little bit less than 4. And then we'd have to divide both sides by this 1.3 to get x alone. So x would equal 750 times 3.875 divided by 1.375. So if we did that in a calculator, we should get the answer D, a little bit more than 2,000 miles. So the hard part there is setting up your proportion. Once you do that, this is your answer. We just write that out. You're going to need a calculator or do some long division to get there, but your answer is a little bit more than 2,000 miles. So with that in mind, we should be okay on this section. We've got more work to practice on, and we're moving on to harder things as we finish up this section.